Right, for number 1, we are doing our derivatives. And for this one, the derivative of any constant we need to remember is 0. So here we have y prime is 0. For number 2, we are doing our derivatives individually since we have some kind of polynomial here. So I have y prime equals 9x to the 8th plus. Now this 3 is going to come down to be part of our answer, and then the derivative of tangent x is secant squared x. Number 3, we do need to change x to the 1 over x to the 4th to be x to the negative 4. Then we have minus 4 cosine x. And if you want to think of this as separate, you can. So then we have y equals negative 4 x to the negative 5th minus 4 times, and whatever the derivative of cosine is, which is negative sine x. And so our final answer here is y prime equals negative 4x to the negative 5 plus 4 sine x. Okay, number 4, again, doing some rewriting with these problems. We have y equals, this is going to be x to the 1/3 power, plus, and we can think of this as 7 times e to the x. We can look at it separately. Sometimes that helps. So y prime is going to be 1/3 x to the negative 2/3 plus 7 times the derivative of e to the x we said was stuff prime, so derivative of x is 1 times e to the x. So that's really just going to be 7 e to the x. So number 5, f prime at x equals derivative of 2x is 2 minus, and again, think of this as 7 times the natural log of x. So 7 times that derivative. This is stuff prime over stuff. And you can rewrite that to be 2 minus 7 over x if you want to. I don't care if you rewrite it. Okay, so number 6, again, f prime at x is going to be equal to 6x plus 4 minus, here's the stuff, so stuff prime all over stuff. And you're welcome to leave it just like that. Right, for our next set of problems, again, still the same thing. We're taking our derivatives individually here. So number 7, we have y prime. It's going to be negative 10t plus 4. Remember, the derivative of 3 or any constant is going to go to 0. So number 8, again, think of this as 9 times sine of x. So g prime at x is going to be 9 times cosine of x. The derivative of sine is cosine, minus 6x squared. Oh, y'all hear my washing machine. Okay, so now let's look at our next one. We have y prime equals, again, think of this individually, 4 times the derivative of just e to the x is e to the x. It's stuff prime times e to the stuff minus, that's really x to the 1/2, so that's going to be 1/2 x to the negative 1/2. All right, and same is true over here with number 10. And again, it's really helpful if you think of those as individuals. So s prime at t equals 3t squared plus 12t minus 2 times, and the derivative of cosine is negative sine, plus 9 times cosine of t. And you can cancel these out if you want to. And so that's all you're going to do with those. All right, moving on. Now for these, you're going to have to do some rewriting, and you can definitely do our distributive property here. So I'm going to first rewrite this as x to the 4th minus x. And so h prime at x is going to be 4x cubed minus 1. Number 12, again, great problem to have to rewrite here. We have f of x equals cosine x minus 3x to the negative 3. So f prime at x, derivative of cosine is negative sine of that same angle, and then derivative here, it looks like we're going to end up with a positive 9x to the negative 4. And again, I'm all for you leaving it like this. Now number 13, remember this to the second power, that means that you need to rewrite this and full it out. So if we do that, then notice again, we're still working with y. We've not done y prime yet. And if we FOIL, we have 4x squared. Then we have negative 6x. And then inside we have another negative 6x. And then we have a positive 9. So let's go ahead and finish rewriting this. This is a lot of rewriting here. Minus 12x plus 9. And so now we're ready for our y prime. And that's going to be 8x minus 12. The rewriting was more than the derivative, I believe. All right, so for 14, again, think of these as multiplied to those. And so here we have g prime at x. That coefficient of 3 is going to stay. Derivative of e to the x is still e to the x plus 5 times. Derivative of natural log of x, well, that's going to be stuff prime, so that's going to be 2x squared all over stuff, and then minus 2. And whether or not you decide to simplify it, that's up to you. Okay, again, more of the same. Practice makes perfect. And so with our rewriting, again, we have f of x equals 2 times sine of x, think of those separately if you want to, plus x to the negative 2. And so f prime at x is going to be 2 cosine of x, and then minus 2x to the negative 3. Number 16, let's divide that up into 2 separate fractions. And we can only do this when there's one single denominator. I'm about to throw that cat out the door. Okay, so now we can simplify this. So if we do simplify, let's continue writing it the way I have been. That's going to be 5x to the second plus 7x. Dividing with like basis, you're subtracting these exponents. And now we're ready for the derivative. So it's going to be 10x plus 7. All right, same thing with 17. We are going to divide this up. So we're going to have y equals 3e to the x over e to the x plus 2e to the 2x over e to the x. And so those are going to cancel. And so that's just going to give me a 3 plus, we have 2e to the x's on top and 1 on bottom. So those are going to cancel, leaving 1e to the x. So I'm going to have 2e to the x. Now we're ready for the derivative. Derivative of 3 is going to be 0 plus, and then remember that's separate, 2 times e to the x. And the derivative of that is going to be just 2e to the x. So y prime is just 2e to the x. Okay, so same for this one. Let's divide this up into different fractions. And so we're going to have g of x equals, and this is going to be x cubed over x squared plus 5x squared over x squared plus 2 over x squared. And then you can go through and simplify. So we have x plus 5 plus 2x to the negative 2. And now we're ready to write out our derivative. So we have 1, and that 5 is going to go to a 0, derivative of a constant 0, minus 4x to the negative 3. Okay, so more rewriting. So we have f of x equals x to the 1/2 plus 9x to the 1/3. And so f prime at x equals 1/2 x to the negative 1/2 plus, and that's going to give us 3x to the negative 2/3. Number 20, more of the same. So we have f of x equals x to the 1/2 minus x to the 1/3. And so f prime at x is going to be 1/2 x to the negative 1/2 minus 1/3 x to the negative 2/3. So 21. Here at least we don't have to rewrite. We have s prime at t equals 3/4 t to the negative 1/4 minus 1/3 t to the negative 2/3. Number 22, more of the same. So we have g prime at x equals 2/3 x to the negative 1/3 plus 1/3 x to the negative 2/3, and then plus 2 cosine x. Okay, and again, more dividing up. So the more practice we get, the better off we'll be. So here, dividing this up, h at x, that's going to be x over 3x minus, this is 6x to the 1/2 over 3x, and that should simplify. So we have h at x equals, and that's going to simplify to 1/3 minus, well, 3 cancels into 6, leaving 2. And top exponent minus bottom exponent, that's going to give me a negative 1/2. And now when we're ready to do our derivative, h prime at x is going to be a positive x, and then subtracting 1 to the negative 3/2. Number 24 we will omit. That's going back through our factoring of cubes, and we're not going to do that right at the moment. Okay, so for number 25, again, think of this as separated, and 5 is that coefficient. So, and then here we have our stuff. So f prime at x is going to be 5 cosine x minus stuff prime back over stuff. You're welcome to leave it like that. Right, now for these, this natural log of 2 and natural log of 3, that's just like having a 2 and 3 sitting there. Those are just coefficients. They're meant to throw you off. So we're really dealing with these derivatives, and these values are just going to sit there. So we have h prime at x equals, and so that's going to be 3 times natural log of 2 x to the second minus, and then for this next one, again, natural log of 3 is just the coefficient times, and the derivative of e to the x is still just e to the x. Now, if we had a variable here, then this process would be a whole lot different, but since it's just natural log of 2 and 3, there's not much difference there. Now for 27, we do need to rewrite this portion. So we have y equals natural log pi x minus 2x to the negative 3/2. It's exponent over root. Now we're ready for the derivative. Here's the stuff. And so the derivative of pi x is just pi back over pi x. And then we're going to have minus, and we're going to multiply this negative 3/2 down. So that minus turns to a plus 3, and then x to the negative 5/2. All right. So looking at 28, we do need to separate this out. So I'm going to rewrite it. And we have natural log of the square root of x. So I'm going to go ahead and write that x to the 1/2, and then minus natural log x raised to the pi power. So our derivative here, g prime at x. Here is the stuff. So stuff prime, that's going to be 1/2 x to the negative 1/2 all over x to the 1/2. And then minus, again, here's the stuff. So we're going to move our exponent down to the front. So pi x to the pi minus 1. And we are going to leave it just like that. Okay, and again, same stuff. Same thing. So don't let it mess you up. Good practice here. So that is 4 times tangent x, 2 times cosine of x. So our derivative is going to be 4 secant squared x, and then the derivative of cosine is negative sine, so that's going to make that positive 2, negative 2 sine x. And then over here with number 30, again, everything looks like it's okay, so we can go ahead and just write out our derivative. Alright, so we have y prime equals, now notice this is not e to the x, that's e squared. So that's just a number there, so that whole term is going to go to 0 minus 2 times e to the x. Well, the derivative of that is still just 2e to the x plus the derivative of sine is cosine of x. And then minus cosine of pi. Well, cosine of pi is just negative 1, which is just going to be a value, a constant value, so that's going to go to 0. So our derivative really ended up being negative 2e to the x plus cosine x. Alright, so for this next problem, we are asked to find the equation of the line tangent to the graph at the point 1, 0. So I'm going to put 1, 0 over here. So that equation of that tangent line, that's still going to be our point slope formula that we used on the last material. So we still need that y minus y1 equals m times x minus x1. This is our x1 and our y1. Now to find m, that's why we need a derivative, because we need the derivative of this, and then we're going to sub in. So y prime equals, well, the derivative of the natural log of stuff, it's going to be stuff prime over stuff. And now to get our slope, m is going to be equal to, we're going to sub in 1. So I'm going to have 2 times 1 all over 1 squared. And the reason why I'm doing that is because this x value here and here is the same x value that we have up here. So all that's going to give us 2. And so our equation is going to be y minus 0 equals 2 times x minus 1. Or we can say just y equals 2 times x minus 1. And there's the equation of our tangent line. Same is going to be true over here. Now we do need to rewrite that x. So let's go ahead and write that as natural log of x to the 3/2. We are going through the point 1, 0, and we need to find y prime, which is going to be 3/2 x to the positive 1/2, sorry. And that's all over x to the 3/2. And this is a great example of why we don't deal with all of that algebra unless we just have to. We're going to sub in a 1 for x. Well, notice that y prime evaluated at the point 1, 0 is just going to be 3/2 times 1 to the 1/2 power over 1 to the 3/2 power, which all of that goes to 1, so I'm just left with 3/2. So here we're ready to write our equation. We have y minus 0 equals our slope, 3/2 times x minus 1, or we can just say y equals 3/2 times x minus 1. All right, continuing the same type of problem. let's go through and find our derivative. So we need f prime at x is going to be 12 minus 3x squared. And we want to find where the tangent, find the points on the graph where the tangent line is horizontal. Well, we got to use the fact that a horizontal line, and let's write this little fact in, which most of y'all probably remember, that a horizontal line has a slope of 0, which means, or we can say therefore, that's where f prime at x equals 0. That's what we're going to look for. F prime at x and m are interchangeable now. So that means that my slope is 0. So here we're going to have 0 equals 12 minus 3x squared. I'm going to add 3x squared over. Divide by 3. Now be super careful here. We're going to take the square root of both sides. So that means x is equal to plus or minus 2. Now it wanted the points on the graph. Now this is just the x coordinate. So that means I have 2 comma something, and it's not 0. Now our slope was 0. These points are on f at x. It's on the original. So we've got to come back up here and plug in 2 and negative 2. So be careful with that. If we plug in 2, remember we're looking for f at 2, not f prime. This is where notation really makes a difference. Well, if we plug in 2, that's going to be 24 minus, and let's see, 2 cubed is 8. So that's going to give us 16. And then f at negative 2, well, that's going to be negative 24 minus a negative 8. So that's going to be negative 16. So there's our 2 points on our graph. Oh, wait, no, don't box anything in. Just leave it like that. Let the AP reader find it. All right, so let's do this again. Same type of problem, same type of question. So what we're going to do is find our derivative, and we are setting that derivative equal to 0 because I want to find the horizontal tangent. So g prime is negative 8x to the negative 3 plus 8. And let's see, that one's going to go to 0. So we're going to set this equal to 0. We have negative 8x to the negative 3 plus 8. I'm going to subtract my 8 over, so negative 8 equals negative 8x to the negative 3. Divide both sides by negative 8, so we have 1 equals x to the negative 3. And the only number I can think of that I can raise to the negative 3 and still have 1 would be 1. So we found x to be 1. Now sub it all the way back up here. Oh, not f. We've got to find g at 1. So when we plug in a 1, we're going to get 4 plus 8 plus 1, so it looks like we get 13. So the place on this graph where I have a horizontal tangent line is at the point 1, 13. Right, so now instead of giving us both x and y, they've just given us x. So the first thing I would do here is try to find y. So let's go ahead and find f at 4. So f at 4 is going to be 24 minus 16 times the square root of 4. So we're going to have 24 minus 16 times 2. So it looks like this y value here is going to be negative 8. So now I know that my ordered pair is for negative 8. Now the next thing I need to do is find the derivative and then substitute in 4. So I have 6 minus, and let's see, this is really x to the 1/2, so that's going to be 8x to the negative 1/2. Notice the notation here. Now we're finding f prime at 4. So I have 6 minus, 8 times 4 to the negative 1/2. So we have 6 minus 8 over the square root of 4, which is 2. So it looks like f prime at 4 is going to be 2. Now we have everything we need to write our equation. Y minus negative 8 equals 2 times x minus 4. And so remember that's going to be plus a positive. And I would go ahead and just move that 8 over in case we had to do some kind of evaluation. So I have 2 times x minus 4 and then minus 8. All right, same thing with the next problem. Even though it's trig, it's still doable. So here, again, first thing, we need to find g at 3 pi over 4. We need to do that substitution. So I have sine of 3 pi over 4 plus cosine of 3 pi over 4. And so sine of 3 pi over 4, 3 pi over 4 is going to be in the second quadrant. So I'm going to have root 2 over 2 minus root 2 over 2. Oh no. So that means we have a 0 there. So that's going to work out to be nice and neat. And now we need our derivative value. So now we need to cosine x minus sine x. Now we need g prime at 3 pi over 4. So we're going to have cosine of 3 pi over 4 is negative root 2 over 2 minus root 2 over 2. So that's going to be negative 2 root 2's over 2, which should simplify down to just negative root 2. So we're ready to write our equation. So y minus 0 equals our slope, negative root 2, times x minus 3 pi over 4. Okay, so for 37, we are solving for variables a and b. So the first thing that we know about this is that h at 1 is 0. So that means I'm going to plug in a 1 for x and then set everything equal to 0. So if I do that, then I'm going to have 0 equals 1 squared plus a times 1 plus b. So I'm going to move that 1 over. So I have negative 1 equals a plus b. And then we also know this about the derivative. So let's find h prime at x is going to be 2x plus, and a is just the constant there, or the coefficient of x, and b is a constant value, so that's going to go to 0. And so I know when x is 1, h prime of x is 4. So I'm going to have 4 equals 2 times 1 plus a. So that tells me that a is 2. And then we can come back over here and sub that in to find b. So I have negative 1 equals 2 plus b. So b must be negative 3. All right, so let's do our last problem. Find the equation of the line perpendicular to the tangent curve. Now, perpendicular lines have negative reciprocals. So it sounds like if we're doing the equation of this line perpendicular, well, we know x is 2, so I need to evaluate y at x equals 2. And when we do that, I get 2 cubed, so that's 8 minus 3 times 2 plus 4. So that looks like that's going to generate 6. So I now know my ordered pair is 2, 6. Now we need y prime. Y prime is going to be 3x squared minus 3. So y prime evaluated at x equals 2. That's going to generate the slope of the tangent line. So that's going to be 3 times 4, which is 12. 12 minus 3 is 9. But if we want the line perpendicular, then I need the negative reciprocal. So the slope of that perpendicular line is going to be negative 1/9. And so now we're ready to write that equation. So we have y minus 6 is equal to negative 1/9 times x minus 2. And that should generate our equation for us.